So, last class we have finished up to sectioning and different types of sections. Just overview. First one is your full view, cutting plane passes entirely across the object. Second one is your half section, only half of the, when there is a symmetry both the sides, only half of the sectioning can be done. Then offset sections, if there are full section where the cutting plane makes right angle bend through the part to show the details at different depth and height, to show the parts in different depth as well as in height, in that case you need to have your offset section. Then rotated and removed sections, middle part how it looks, then it has been rotated to see both the sides how it looks, both front as well as rear. Then this rotated section has been removed and placed separately. As I vary from section to sections, the removed sections looks like this. It is changing from one plane to other plane. Then aligned sections, if there are cases where your holes are not symmetric and at the same times maybe holes are different holes, then you can put a aligned section so that you can show features inside this hole. Then last one is important one, that is your assembly sections. Particularly it has been used in automobile, where different part you have to first assemble and prepare the object and take the sections and show the sectioning of different parts. That means, it is a combination of different parts. Example, these are the different parts and it has been assembled first, then sectioning has been made. This part also I have completed drawing practice for sectional view. Just for a preview what I have completed last class. Now, if you looked at here, hidden edges surfaces are not shown unless it is not required. Then visible details shown in the sectional view. Once you take a section, inside the sectional view visible details, example 1 A and B. So, example A is incorrect, particularly taking at section here. For A it is incorrect, but section taking at section the sectional view in B it is correct. Now, come to your hatching. For different materials there are different types of hatchings. Once you put that hatching during sectioning, that means it shows that that material is made up of what kind of material. If you looked at here cast iron, how is your hatching has been done, and steel, particularly steel, two parallel lines, then there is a gap, steel is two parallel lines, then there is a gap, again two parallel lines, parallel to earlier two parallel lines, two parallel lines. So, once you do the hatching, then somebody can recognize this material is made of steel. Bronze, brass, copper and compositions, how it looks? It looks one solid line, then parallel dotted line, then solid line, then parallel dotted line, then solid line, then parallel dotted lines. White metal, zinc, lead, alloys, how it looks? Wood, how it looks? aluminum. Aluminum you have to do the hatching this, electrical windings, sound insulations, cork, leather, rubber and plastic, look at the rubber and plastic, then titanium and refractory material, concrete. Concrete is very, this is a standardized symbol for civil engineering, concrete, thermal insulations, marble, then water also you can show it, sand, rock and earth. These are all few examples, sometimes what happen, these are all standardized. Once you do the hatching by means, the designer can understand this material made up with this cast iron. Beyond this any material, if you are getting any material during your sectional view that is not standardized, always you can prescribe with this. I can always in the side I can show that this is made of, you can say that this is cast iron or iron. In this way you can always you can show your this material. Meaning of showing solid portion of a object, different hatching for different components. We have started now hatchings. First one is your means of solid portion of the object, solid portion of the objects, what are the different hatching lines. Now different hatching for different components. It may possible this material, particularly in this case, this material is a made up of steel with filled by means of by stopper by means of a cock. So look at here, by means of this hatching it shows that this material consists of steel and this is a cork. Even if made of same material, even if it is made of same material, look at here, even if it is made of same material, the hatching should be, preferable direction of the hatching should be 30 degree, 60 degree and 75 degree. This is your preferable directions. With respect to that, it should be 30 degree, 60 degree and 75 degree. It should not be arbitrary. In this case, this is wrong, because here hatching angle is different, here this side hatching angle is different, because this material consists of the same material. Once you cut it, there is a void here, this material is the same material. So, for the same material different hatching cannot be done. So, this is wrong. If you looked at this side, this is right, because this material is there. Again direction of the hatching has been maintained with this 30 degree. So, 3 hatching has to be done with a direction particularly 30 degree, 60 degree and 75 degree. This is second principle, this is correct. Now, direction of hatching for the same object, if I cut it, then I have taken out the front and looking at the from the front side, front view, how your hatching is. It should be in the direction of the hatching for the same object, section at AA, same object, same direction of hatching. Look at this, same object, same direction of your hatching. If you looked at the both these objects, same object, only hatching is different. If you looked at here, in this case hatching in the same directions, 60 degree directions, but here one part is reverse direction, one part is the 60 degree directions. That means this is completely wrong. You cannot do same object, suppose this is the object, for example this is the object, this is a hollow part and this object is made up of steel. If I do the hatching, I will do it here, similarly I will do it here. I cannot do this side particularly, how it is wrong, I cannot do this side this way of hatching, this is wrong. If you want to maintain, then you have to maintain same in the both the sides. Now, let us start with examples, few examples. Block with a hole, example 1, there is a block and with a hole. Imagine this block, there is a block and if I look at this isometric view, this is a block, there is a hole at the top, this hole is continuing up to certain distance, then after that there is an inner hole also there. That means this hole is not throughout. Now you are looking this object from this side, take this object from the top view, you can put it at the top view, then front view you draw how it looks, then take a cutting plane in such a way that you can see the inside features or inside view. I am taking a cutting plane in the symmetry with a vertical axis, so that it pass at the center of the hole, so that it is symmetry, so that I can see it. So, now this front view, if I am looking at this, these are all your hidden lines, how it looks inside. There is a hole here, then inside there is a hole, then at the middle there is this, then outer it is this. Now, you are taking out this, this material is made up of what? After this hole, this material is made up of, the moment I am doing this hatching, it is made up of steel, cast iron. So, both the sides the material is same, that means the entire material is same, only there is a drill at the top and at the middle. Then block with two holes, look at the block, there is a block, two holes opposite to each other, example 2. Now, what is your view? What kind of sectioning I want to do it? These are not symmetric, rather this is diametrically opposite. So, aligned sectioning, in this case aligned sectioning has to be done. Now, a plane has been taken here, passing through the hole, then with your 90 degree and taken center line of the hole, second plane is going, that means it is aligned. This is your cutting plane you have to choose, choosing of your cutting plane is more important. That means you choose in a such a way that it should pass through this hole, so that hidden part of the hole you can see it. This is a top view. Now, aligned sectioning you are doing, cut it, this is a front view. Now, look at this hidden part, this is inside hidden. Now, look at the sectioning, that means the entire material consists of, entire object consists of same material except these holes. Block with 3 holes, there is a hole here at the top, that means this hole is at the same center line or aligned, you can say that it is aligned, but at the same time there is another hole, this hole is not throughout, rather it started with the bottom, up to certain section this hole is there. Then you have to start with this aligned sectioning, that means you align here, then take the plane so that this hole can be cut it, third hole, then take out this plane, again it will go to your other hole. Look at your top view, this is the hole. Now, plane has been passed through first hole, aligned back, then it has been passed through your hidden hole, then again aligned back, then it has been passed through your second hole. So, that once I take it out, I can, once I do the plane cutting plane here, if I take out here and looking from the front, that means this half I can see, this half I can see, this half I can see. How it looks? Then these are all your holes, then object is made of the same material. So, it should be hatched with your same lines, and either it is 30 degree or maybe 60 degree or maybe 75 degree. Block with 3 holes, different cutting planes. Look at these 2 examples. It is a one cutting plane, it is a different cutting plane. One cutting plane is aligned like this and cut it and pass through the cutting plane along this hole, so that you can see it. This is my top view, how your front view looks like, and how the cutting plane has been made. Now, after this example, these are all brief examples about your aligning, means how your cutting plane you are passing throughout the sections and how you are going to visualize. We will continue with few more complicated examples. Now, center lines, line styles and conventions. Before I go for further few more examples, this is your center lines. I have said also earlier center line, this is your center line, then crossing of your center lines, this is your crossing of your center lines. That means, if there is a circle, then crossing of the center lines, here it is going, then that means this part is your crossing of your center lines. Then sectioning lines, look at the sectioning lines, how it looks your sectioning lines. If I say one half has been sectioning line has to be plot, how your sectioning lines, one line, two dash, then continuing a second line, one line, two dash, continuing second line, then both the lines should join, there should not be any gap. Principal planes, this is center line. Now, look at your half sectioning, this is your object, how it looks your half sectioning. The moment I say it is full sectioning, that means from here to here, the moment I say it is full sectioning, from here to here the cutting plane should be throughout, and I will take out half and look at it. Why it is half sectioning? This is axis symmetric problem. That means, throughout if I take 1/4, half of the sectioning, whatever I am going to see, it will be throughout same. So, one half of the material has been taken out, then looking at how it looks, how your plane, sectioning plane, how you cut it one half, then like this it has been cut it like this, instead of cutting plane this way, it has been made it this way, or you can make it this way. Full sectioning, you can cutting plane like this, half sectioning, you can make it this way, joining your points end to end, lines end to end. Now, no sectioning, there are other certain conventions, other conventions, no sectioning, shaft, particularly shaft, remember number 1 shaft. So, shaft does not give any details. So, that means if there is a shaft, in case of shaft, no sectioning should be done. Look at your shaft, I cut it at the middle, that means half, full sectioning has been done, then the material has been taken out, how it looks your shaft, that means no sectioning has been done, particularly in shaft. Have you marked it? This is your shaft, this part is your shaft, it is going throughout. This is a material and this material has been put it, but the moment you cut it, the shaft has not been sectioned. Cut it in this way, how it looks. Look this example very carefully, does not give any details of the shaft. Now, there is a shaft is going inside material, the shaft is going. Now, how it looks, I am looking at the from the front side, front view. Now, this is your top view. Now, it has been cut it at the center. So, now it has been full sectioning has been made. How it looks? It looks like this. Then along the shaft, if you look at why particularly in shaft no sectioning has been made, along the shaft directions you align another sectional plane, another plane, how it looks. I am taking along the shaft, the plane, cut it and looked at how it looks. It looks as a shaft. So, rule number 1 for shaft no sectioning is required. No sectioning for screws. Screws does not give any details. These are the screws. Common uses, it does not give any details. So, no sectioning. Now, look at the screws, take out, do the sectioning, you are not going to get inside anything else. No sectioning, ribs and spokes, particularly ribs and spokes, these are the ribs. Now, if I cut it, how it looks? Then take the sectional view, look at here, no sectioning for ribs and spokes. Now, we can rotate the ribs, I can rotate the ribs, rotated sections. If there is a rib of these planes and these planes, here it is a symmetry line. So, you can rotate it back, bring back your center line of your sectioning. Exactly it has been done, it has been rotated back, it has been rotated back. So, you can show it symmetry, so that people can understand it has been rotated back. Again no sectioning for ribs and spokes, same thing. Look at the inside feature of the ribs, no sectioning. No sectioning means no hatching. I am not doing any hatching here, because these are my rib part, these are the materials connected by the rib, here, 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 but this is the material. So, here it is no sectioning, that means no hatching. Rotated section, holes. Suppose there are 3 holes not aligned with each other, then always you can rotate. If you look at here these holes in a plate, 3 holes, then take a section, draw the top view, draw the sectional line where you are going to do this sectioning and which view, which side you are going to view. I want to do the sectioning, cutting plane, putting here and taken out the entire solid of my front face and looking at the from the front view. Then what you are supposed to do? You rotate this hole back to here, or maybe you can rotate it back to here, put it in the align, in the center line. It has been rotated, put it here, so that it is equidistance, so that center here, then other material is your same material, the material is your same material. I cannot do the sectioning like this. Look at the conventions. You have to rotate by means of imaginations. It is not necessarily you have to show by means of arrow, but by means of imagination you have to rotate it, but you cannot do the sectioning either by aligned or by offset sectioning, you cannot do it. Look at here, this is wrong, and this side by imagination it has been rotated, so that this hole has been rotated, so that this hole has been aligned along the center line, then taken your sectional view. Rotated section, logs, these are the logs. So, looked at this same way, logs are there, this is center line where your sectioning has been done. Then what you are supposed to do? You cannot do it by means of offset sectioning or by means of aligned sectioning, rather this is wrong, rather you want to rotate it and align it and show the rotation part. Rims, look at the rim, revolved section, rim, there is a rim here. How the sectioning has been done in the rim, not the entire rim, the revolved section how it has been done, one part. Start with this typical and kind of a, you can say that this is assembly. If you remember well, different types of sectioning: full sectioning, half sectioning, offset, aligned, rotated, removed, and other one is your assembled section. Now, we are coming to assembled section. Wheel with a solid wave continuous around the axis. There is a wheel with a solid wave continuous around the axis. Webbing is hatched, in this case webbing is hatched, looked at here, how it looks, then how it looks, then I cut it. Wheel with spokes not continuous around the axis, spokes are not hatched. What is the difference? First one is wheel with a solid wave continuous around the axis, solid wave continuous around the axis, then it has to be hatched. With spoke, these are the spokes which is not continuous around the axis, it has been put here, here, here and here, it is not continuous throughout, then in that case spokes are not hatched. When wave or spokes are continuous around the axis, then hatching is required. If it is not continuous, then hatching is not required. Look the difference. Here in this case, this is continuous around this solid wave, then it has been hatched. So, here in this case the spokes are not continuous, rather it has been placed 4. So, it is not hatched. Nozzle with solid material continuous around the axis. Nozzle with solid material, there is a solid material, then there is a nozzle, but it is continuous throughout the axis, then material has to be hatched. Material has been hatched. Then look at the difference. Nozzle with ribs which are not continuous around the axis. Nozzle with ribs, these are all your ribs, this, ribs. The ribs are not continuous, rather it placed the nozzle connected, you can say that it is connected. So, in this case ribs are not hatched if I take it, but here nozzle is with solid material continuous around the sections, that means entire material has been hatched. If you look at here, only material is hatched and this is not hatched, no sectioning. Conventionally big logs are hatched. Look at here, these are all big logs, there are logs, earlier I say logs should not be hatched, now I am saying big logs are hatched, big log. Now big logs are hatched. If log is big dimension wise, this is a judgment you have to take it, which log is big, which log is not big. This will come over the period of time. Once you start practicing problems, whatever I am showing it, if you practice it at your home, then it will come the conventions automatically in your mind that this has to be hatched, this is not going to be hatched. But small logs are not hatched. Compare it, this is a big log, now there is a small log, these are small logs, these are not hatched. Big logs versus small logs, look at the difference. Notice that big logs is hatched, but the small log is not hatched. In a solid there is a big log as well as there are small logs. small logs and there is a big log, here it is a big log. So, big log has been hatched, small log has not hatched. So, once you do this drawing, once you show the sectional view in an way, this gives an indications this log is a big, that is why this hatching has been done. This log is a small, that is why there is no hatching. Fasteners, pins, shafts, bolt heads, rivet heads are not the or are not supposed to be hatched. Fasteners, pins, you put the pins inside, then bolt heads, these are not supposed to be hatched, like screw, these are not supposed to be hatched. So, I will stop it here. So, next class I will start assembly sectioning with typical 2-3 examples, so that it will be very easy for understanding. Thank you.